y equal to fx equal to root over of 6 minus 6. Now, root over of 6 minus 6, when this will be defined. Here, this will be defined with the largest possible domain. When this whole thing is greater than equal to 0. So, we'll start in this way. The given rule of correspondence. The given rule of correspondence is defined with the largest possible domain when 6 minus x greater than equal to 0. This means x less than equal to 6. And this implies x belongs to minus infinity comma 6 closed. Therefore, domain is minus infinity comma 6 closed. That for all f existing. It is given fx equals to x minus 2 by x squared minus 3x plus 2. Now this function is in what form? Gx by hx form. This function is of the form gx by hx. Now gx is a linear polynomial. Gx is a linear polynomial in x. So Gx is defined for all x belongs to R. Therefore, domain of G is R. Similarly, Hx is a quadratic polynomial. Hx is a quadratic polynomial in x. So Hx is defined for all x belongs to R. Therefore, domain of H is R. Next, we find out when Hx is 0. X squared minus 3x plus 2 equal to 0. Now, I told all of you that if the sum of the coefficient is 0, one of the root of the expression is 1. Product of the root 1 into, suppose the other root is alpha. So 1 into alpha is 2, so alpha is 2. So here we have two roots, 1 and 2. So Hx will be 0 when x is 1, 2. Domain f equal to domain of G into domain of H minus those values of x for which Hx is 0. So R minus set continuing 1, 2. That's the equation. Here you can add one line. If you add one line, that is for all x belongs to R minus set containing 1, 2. Fx is defined therefore domain is all large possible domain of f is R minus set containing 1, 2. Fx is given by root over of 2 2 plus x minus x squared. Now we have to find the domain of this. So write down the given rule of correspondence will be defined, will be defined with the largest possible domain, with the largest possible domain when 2 plus x minus x squared greater than or equal to 0. We take minus as 1 greater than equal to 0. We transfer minus sign on the right hand side and we get less than equal to 0. Now we factorize this. X squared minus 2x plus x minus 2 less than equal to 0. Now middle term is been done. So x minus 2 plus 1 into x minus 2 less than equal to 0. This gives x plus 1 into x minus 2 less than equal to 0. Now we take a number line from minus infinity to infinity, minus 1 to plus on the right hand side the highest critical point, power odd sign changes, second power odd sign changes. So we get that x belongs to minus 1 comma 2, which is the required domain. So we write here the domain of f is minus 1 comma 2. Under root of 12 minus x minus x squared. Let us consider this function as fx and we write fx equals to under root of 12 minus x minus x squared. So the given rule of correspondence will be defined with the largest possible domain, with the largest possible domain when 12 minus x squared greater than equal to 0. We take minus sign common to make the coefficient of x square as 1 and we get x square plus x minus 12 less than equal to 0. This gives us on middle term as x square plus 4x minus 3x minus 12 less than equal to 0. Here we take x common, x plus 4 minus 3 into x plus 4 less than equal to 0. Now here x minus 3 into x plus 4 less than equal to 0. Now we take a number line to understand where the x lie, or the interval where the x lie. So here the critical points are minus 4 comma 3 plus on the right side the highest critical point, power odd sign changes, power odd again sign changes. So here x belongs to minus 4 comma 3 Therefore, required domain of the function is equal to minus 4 comma 3 closed. Y equal to fx equal to x square by x square plus 1. Now, we observe here that x square can be, always can be, or not can be, it should be greater than equal to 0 for all x belongs to R. So x square plus 1 will be definitely greater than 0. So this will be never equal to 0. And is also the form here directly you can see from this one that the domain will be R. Because these are here, this is a polynomial of degree 2. This is a polynomial of degree 2. Both will have the domain R. And denominator can never be 0. So domain is R. Now see the writing one. So fx is given x square by x square plus 1. We take this as gx by hx. And then we write gx and hx are polynomial functions of degree 2 of degree 2, that is quadratic polynomial. Quadratic polynomial. Therefore, domain of G equal to R, domain of H equal to R. And next, what we find for how to find this domain of fx, domain of G into domain of H minus those values of x for which h is 0. Now, here for all x belongs to R, which we consider domain of the function hx. For all x belongs to R, x square greater than equal to 0. Now this implies x square plus 1 greater than 0. Therefore, hx greater than 0. So no question of x to be equal to 0. So by algebra of function, what we can say? The domain of G innocent domain of H minus those values of x for which hx is 0. Now here hx is not 0. There is no value of x for which hx is 0. So what will get? We'll get here R. So domain of f is what? R. Or you can say largest possible domain is what? Domain of f is what? R. Domain of f is R. We'll find the domain of the function y equal to log x base 10. So for domain, what we do? We take the graphical representation of log. This is a log graph. Log x base 10. Now, this is the log x base 10 graph. All of you know. So, this is a graphical representation of this one. Log x base 10. Base is greater than 1. Now, here what we observe that if we take any positive real number, that is any value of x greater than 0, then what we see? You get a defined output. When you take any positive number, here you can see we are taking this value, we are getting this output. We are taking this value, we are getting this output. We are putting this value, we are getting this output. We are putting this value, we are getting this output. So if you take any positive real number, then it is what? And this is the graph we are talking about. Now this is the graph we are talking about, and here what we observe, we take any positive real number, we put any positive real number as the input. We take any positive real number for the value of x, we get a defined output. We get what? We get a defined output. Any positive real number you put here, you will get what? You get a defined output. Therefore, what we will say here, domain is what? Domain is R plus. That means here domain will be 0 to infinity 5. Because for all x belongs to 0, infinity, y equal to log x base 10 is defined. fx equals to x plus 2 by under root of x square minus x minus 2. Now this function can be taken as gx by hx, where gx equal to x plus 2, which is a linear polynomial. Therefore, domain of G is R. Hx is under root of x square minus x minus 2, which will be defined with largest possible domain. When x square minus x minus 2 greater than equal to 0. So x square minus 2x plus x minus 2 greater than equal to 0. So here x into x minus 2 plus 1 into x minus 2 greater than equal to 0. Here x plus 1 into x minus 2 greater than equal to 0. Now if we take a number line, what we do is minus infinity to infinity, minus 1, 2. So plus power or sign changes, power or sign changes. So here x belongs to minus infinity comma minus 1 closed union 2 to infinity. So here after this you know that domain of f is what? Domain of G is domain of h minus those values of x for which hx is 0. So we write here domain of A equal to domain of G initial domain of h minus those values of x for which hx is 0. So we take a number. Infinity to infinity. Here what we have minus 1 and so minus 1 and now since G is the whole real line, so only the part where h is there that only we can consider and we cannot take this values. Why? Because when we take minus 1 and 2, h will be 0. Therefore, required domain is minus infinity comma minus 1 open union 2 to infinity. Both open because we cannot consider these two elements. And that is the required domain. Y equal to 1 part sin x minus cos x. Now here this is having the domain R, so only this one we have to check. Here sin x and cos both have the domain R. We have to see only when this is not equal to 0. So we can write it in this way. The given rule of correspondence will be defined when sin x minus cos x not equal to 0, and that gives tan x not equal to 1. That implies tan x not equal to tan pi by 4. So we can write this one as tan x minus tan alpha. Now which means sin x by cos x minus sin alpha by cos alpha equal to 0. This gives sin x cos alpha minus cos x sin alpha equal to 0. Sin n pi, if we take where n is some integer, what we get? Sin 2 into n into pi by 2 plus 0. 2n means sin will be remaining as sin. So this is sin 0, which is 0. That means if we take sin n pi, where n can be any integer, n can be 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, the sin n pi will be giving us 0. Now, sin x minus alpha equal to 0, so this means so sin x minus alpha equal to sin n pi, where n belongs to 0, or instead of writing this step, we have to write this one directly. N belongs to 0. So this means what? X equal to n pi plus alpha, n belongs to 0. Now, here we'll substitute that value, that x not equals to n pi plus pi by 4, n belongs to 0. So required domain will be what? R minus set continue n pi plus pi by 4, where n belongs to 0. We're trying to find here domain of fx equals to 1 by under root of x minus 2 into 3 minus 6. Now, this function will be defined when this whole thing is greater than 0, when this whole product is greater than 0. So write down the given rule of correspondence will be defined with the largest possible domain with the largest possible domain when x minus 2 into greater than 0. We can rewrite this as x minus 2 into x minus 3. We take a minus sign outside greater than 0. This gives x minus 2 into x minus 3 less than 0. Now, all of you know, we'll take a number line with the method 2, 3 as the critical points. On the right hand side of the highest critical point, we put plus, because if you take any number more than 3 and put it here, you get positive value of this expression. Now 3 is coming from this one, power is odd. So the sign will change. Next 2 is coming from this one, power is odd again. So sign will change. What we need less than 0. Less than 0 means this portion. When x belongs to 2 to 3, the whole expression is less than 0. We observe for all x belongs to x minus 2 into x minus 3 less than 0. And this implies x minus 2 into 3 minus 6 greater than 0. That is, fx is defined in this range. And is the largest possible domain which you can have. So required domain is open bracket 2 comma 3. See here. At first, the definition, the statement which I told you always that you write it this way, that given rule of correspondence will be defined with the largest possible domain when this whole thing is greater than 0, we have written that greater than 0. Now after that we become method and we have simply plotted this, and ultimately we have seen that for all s belong to this is defined instant. Sine inverse of 2x. So we take the function as fx equals to sine inverse of 2x. Now we know sine inverse of any variable is defined when that one lies between -1 and 1. That is, if we draw the graph of this is y, this is y prime, this is x prime, origin, and x. Now, if we draw sine inverse, this is the graph of sine inverse. This y equal to sine inverse of x. This corresponds 0, pi by 2. This is -1, 0. And this we get 0, -5. So you can understand when it is defined when x lying from -1 to 1. But here you have 2x. If we have here 2x, so what we can say? The given rule of correspondence will be defined with the largest possible domain when 2x less than equal to 1 equal to -1. This implies x less than equal to half greater than equal to -1. Therefore, x belongs to -half, half. So domain of f is -half, half. Now, if we want to transform this curve to sine inverse of 2x, that also you can do. Just multiplying here x by 2, and here just we divide by half. I mean, so divide by 2. So you get here -half to half, and that's the equal curve. Fx is given by under root of 3x minus 7 divided by 6th root of x plus 1 minus 2. Now, this function sum is of the form gx by hx. That is, we can think this as gx and the denominator one is hx. So, the domain of f is what we know. Domain of g, intersection domain of h, minus those values of x for which hx is 0. These are basic definition. So we'll try to find the domain of gx. So gx is what? It is under root of 3x minus 7. Now this will be defined where gx will be defined largest possible domain domain when 3x minus 7 greater than equal to 0. Since it is only root over of this one we are dealing with, so this will be greater than or equal to 0. And this gives x greater than equal to 7 by 3. Here we can say domain of G is 7 by 3 to infinity. Next, only hx is equal to 6 root of x plus 1 minus 2. Now, when this will be defined, first of all, x plus 1 has to be what? Greater than equal to 0. So you can write in this way. Hx will be defined with largest possible domain. With largest possible domain. When x plus 1 greater than equal to 0. That gives us x greater than equal to minus 1. So this gives us what? X greater than equal to minus 1. Now, when x is greater than equal to minus 1, we can write in the another way, x belongs to minus 1 to infinity. So domain of h is minus 1 comma infinity. Now, next another thing we need to know when hx is 0. We should eliminate those values. So hx equal to 0 when hx equal to 0, then 6th root of x plus 1 minus 2 equal to 0. So this gives x plus 1 equal to 2 to the power of 6. And this gives x equal to 63. So when is x 63, then this will be 0. Now what is the definition? Domain of G is domain of H minus those values of x for which hx is 0. Now the intersection of these two. So domain of G 7 by 3 common thing. Domain of H minus 1 comma infinity. Here domain of G you can see 7 by 3 comma infinity. Domain of H minus 1 comma infinity. We have to take the common part of these two. We are finding the domain of G. So this from minus infinity to infinity. And actually we are finding the domain of not G. We are finding what? dg intersection dh. The common portion of these two. Now common portion of dg and dh. So we can see d starts from minus 1 to infinity. And dg starts from 7 by 3 to infinity. So if we see here, that is, this is our dg and this is the dh. So we can easily understand that dg is a subset of dh. dg subset of, rather proper subset of dh, and therefore dg intersection dh, which we need to find out, is dg only. Now required domain will be what? dg intersection dh minus set of those values of x for which hx equal to 0. 7 by 3 comma 63 open union 63 comma infinity. It is given y equal to log 100x 2 log x base 10. Y equal to log x log of this whole thing, that is 2 log x base 10 plus 2 by minus 6 base 100. So see, observe the sum properly. Y equal log of this 2 log x base 10 plus 2 by minus 6 base 100x. First of all, if we come by definition, y equal to log x base a. So here at first we focus on the given thing, that is y equal to log x base a. So when this is applicable, when this is defined, when x is greater than 0, a greater than 0, a not equal to 1. This is the basic definition of log. Now, first of all, observe here, log x is there. So from equation 1, what we can say, since log x base 10 exists, so x greater than 0. This is the first thing which you can understand. X has to be greater than 0. Next, this log function has been applied over this whole thing. So this whole thing should be greater than 0. Now, x greater than 0 means this implies minus x less than 0. Minus x less than 0 means this part less than 0. So this numerator should be less than 0. Otherwise, this log will not be defined. So this implies 2 log x base 10 plus 2 less than 0. Why? If it is negative, if the numerator is also negative, then the ratio will be positive. Now, we can write here log x base 10 less than minus 1. Log x base 10 less than minus 1. Now, I have shown you the graph of log function. This is log x base 10. This is y. This is x. This is x prime. This is y prime. This is the origin. Now here, if we draw the graph of log this one, when the base is greater than 1, we know base greater than 1 means strictly increasing function. Strictly increasing function means the inequality does not change. If we have here two values, one is x1 and it is x2. It's when x2 greater than x2 greater than y1, so strictly increasing function. We have here strictly increasing function. This is log x base 10 less than minus 1. Now minus 1 you can represent as log 10 to the power of minus 1 base 10. Someone can do it in this way, or someone can directly write by definition that x less than 10 to the power of minus 1. So log x base 10 less than log 10 to the power of minus 1 base 10. So from this, you can understand y2 less than y1. y2 less than y1. If we think this whole thing as y2, this whole thing as y1, so y2 less than y1 means x will be also less than x1. Why? Because this function log x base 10 is simply increasing function. So here what we get, x less than 1 by 10. The third one. So this is done. Now we move on to this one, base. Here base is what? 100x. Base is 100x means this base should not be 1. Since x greater than 0, it is already been mentioned. So 100x is also greater than 0. Only one thing you have to take care of, that is this is not equal to 1. So you can proceed this one as x greater than 0, 100x greater than 0, and 100x not equals to 1. This implies x not equals to 1 by 100. Now this is the fourth point. Now from 2, 3, and 4. See, from 2 what we had? From 2 we have understood that x should be greater than 0. From 3 you have understood x should be less than 1 by 10. And from the fourth one we have understood x not equal to 1 by 100. So we can say that here x is greater than 0, less than 1 by 10, and x not equal to x belongs to 0, comma 1 by 100 union 1 by 100, comma 1 by 10.